Hello, and please welcome. Please sit down, and we will start now. And I'm proud to present Leif, Åstrand. Take it.
Back when I was young. Oh yeah, those were the times. That's when react fast was advice and not a political statement. That one was when centering a div was actually difficult because we didn't have Stack Overflow. That's when I was using PHP. Not because it was good, but because hosting was cheap. We built great websites, great web applications. We did it by opening a file browser to the production server, opening the PHP file, and editing it, and saving. And that was DevOps. Amazing back in those days. I had a colleague. He was kind of a UI developer. I was more of a backend developer, but we definitely knew each other's stuff. We used to sit next to each other. He had the CSS file open. I had the PHP file with all the HTML open. He would say kind of, could you add a class name there? And I would do that. And I said, hey, could you make that pretty? And he made it pretty. And we were a full stack team. Oh yeah, those were the days. Those were the days. But it got better. We got this thing called jQuery. Oh yeah. So now we could do animations. Things were moving around on our web pages. And we could fetch things and update just a small part, not always reload the page. You should have been there. You should have been there. Oh yeah. And sometimes even some clients, they said, we don't want a website. We want a web app. So what do? Well, we build an applet. Oh yeah. That was really great. Or then GWT, so you could actually kind of run it in the web but still do Java. Or maybe also we found this thing called Vaadin, but let's not talk about that. Anyways, now Granny needs an app. So yeah, that was 20 years ago. 2005-ish, when I started my career as a professional software developer. We were using things like jQuery. I mean, we were using even older things that don't even fit on the timeline, like PHP and so on. But really, it kind of got interesting with jQuery, because then you could do things interactive and so on without always reloading the page, because that always felt a little bit bad. And then based on jQuery, there was kind of a whole sequence of things built on top of it. So first there was Angular, popularizing the idea of having HTML templates in client-side code. Then a couple of years later, we got React, which also introduced the concept of state management tied to that thing. So Angular kind of had it, but it was really inefficient. It was polling all the time. But with React, it actually knew kind of when this thing was updated, then that thing should be re-rendered, and that was much more efficient. And then Vue made that even more granular with refs, so that just better. But still, kind of those were really the fundamental things that led us to single-page applications, kind of rounded up by Angular 2 in 2006. This was very much supported by also very big changes in the front-end languages. So ES5 was the first really kind of sensible version of JavaScript. We got things like strict mode, where suddenly things weren't global automatically. We got then TypeScript, which added the concept that, maybe we should have types, because we as Java developers, we know that types are good, but the JavaScript developers at that time, it was completely new to them. And then finally, rounding up the kind of modern web stack in a way with ES6, which added things like classes and modules to JavaScript. Finally, there was also some kind of server-related things happening around those times. We got this thing called Swagger for kind of defining your REST endpoint structures and so on. HTMX actually got started already then. Then it had the name intercooler.js, but HTMX is basically just following on that same thing. And the Next.js, which is kind of React on the server, also happened 2016-ish. And the point here really is, we like to say that things happen so quickly in front-end. And yeah, that was the case 10 years ago. Because nothing interesting, maybe I'm exaggerating a little bit, but almost nothing interesting has happened in front-end since 2016. There's been variations, iterating on those same concepts, small tweaks here and there, but the fundamental stuff, it's really from 2006 to 2016. Those were really the kind of the age of exploration, and since then it's been iteration but nothing more. And what this kind of means is that all of these have been building on top of each other. There's been kind of, someone has done some small project, oh yeah, this looks cool, kind of works, trying it out in a bigger project, ever bigger project, creating a framework or a library to support building things in that way that worked well in that project, and then making it easier to build things in the same way in other projects also, and kind of just gradually learning what are the pros, what are the cons of all these different approaches, and the good approaches ended up as successful frameworks that we now love and use or hate. And then the not so successful ones, they are the frameworks that we have forgotten by now. And that really is what leads us to why I now think, in a way, we are ready for the next stage, which is to go beyond single-page application frameworks, go beyond just Angular, React, and Vue, and take more of a full-stack approach to all of this. So who am I to make these claims? Well, I'm Leif. I have 20 years of bias towards full-stack development, so you can totally trust me on this. I started kind of first 1/3 of my career as a professional software developer. I was building full-stack applications or websites, but kind of the same. Then I joined this company named Vaadin, where we actually build a framework for doing full-stack stuff. So then I became a full-stack framework developer. And then past 6-7 years something, I have still at Vaadin, but more kind of management, kind of general management, product management, architecture, more kind of thinking about how things could be made easier, but not actually writing so much actual production code anymore. Our agenda is a full stack, so you shouldn't read it from the bottom. We already went through the history of how we kind of ended up here. Then I'm going to go through what do I mean by full stack, because I mean, I think every one of you probably has a slightly different definition of what you mean, but I'm going to tell what I mean and kind of show examples of what that looks like. Then we're going to look at why should you care about full stack development? What are the kind of benefits of this kind of approach? Then, yes, but. So whenever I talk about these things, people kind of politely nod and they say yes, and then they say but. There's always some excuse, something that in most cases, in my experience, it's just a misunderstanding. There's kind of, if you look at it from a really simplistic point of view, then yes, that objection makes sense. But if you dig a little bit deeper, it quite often turns out that there's nothing really kind of supporting that objection. Then we will have some QA. Probably there will be some misunderstandings here also. So we'll get those sorted out, and then I will wrap up, and then we will go for coffee. So what is full stack? My definition is basically, it's more about what you not do. It's not what you do, but what you not do. You're not building two different applications. Typically, in any kind of application with UI, there's three layers. There's the presentation layer, there's the business layer, and there's the persistence layer. And the whole point with full stack is that all these three layers are in one application. What very often happens is that you have the presentation layer is a completely separate application, and I'm claiming that's just stupid. The reasons for that, we'll get to that. But what it really means, kind of, it's keeping both the front client side and the server side, keeping them together. You have one team owning the whole application end to end. That team has one set of priorities. There can be specialization within that team. So not everyone needs to be an expert in all the things, but still it's one team. They have one, I don't know if you use daily meetings or anything, but still kind of they keep in touch with each other all the time. They work as a team. They help each other whenever anyone needs help and so on. Everything is in one source code repository. So you have one place where both the front end and the backend lives. This means, very importantly, one single commit can add a whole feature end to end. You don't need to kind of, well, let's commit a little bit to the backend first to have something, and then we wait until a snapshot is built, and then we work on the front end a little bit, and then we commit some changes there, and then we need some changes in the backend, and then we end up committing some more things and going back and forth. But instead, very essential. It's a benefit, and it really helps you avoid going back and forth. Everything in one source code repo, because then single commit can add the whole feature. Finally, kind of directly following from having one repo is that you have one build. You have one build pipeline. Of course, there can be many different steps in that pipeline, but that single commit, it triggers one build pipeline. If either the front end or the back end, they don't work together, then the whole build fails. You don't publish any artifacts. You don't even by accident end up deploying half your application, but instead you always deploy all of it. Typically, you can keep things simple, so you actually deploy just one artifact. It's one jar file that contains the static files for front-end stuff and also the actual Java code for the things that run on the server. Sometimes you might want to optimize that with a CDN, but still the way you think about it would anyways be that it's this kind of the things that go to the CDN and the things that go to the application server, they belong together. They have been built together. They come from the same source code repo. They are owned by the same team. When we think about how I build a full stack application or any kind of web application, quite often the discussion nowadays is, should it be a single page application or should it be a multiple page application? I think nowadays there needs to be a lot more nuance than just those two kind of opposites, because there's lots of very interesting hybrid solutions in between. Another thing quite similar is, should it be server-side rendering or not server-side rendering? Here also there's all these kinds of hybrids and so on, which means that we really need to look at this at a spectrum, not just as kind of these two different poles. So it's a spectrum. You could say it goes all the way on one edge from static site generators all the way to traditional single page application that is actually two different applications. But I'm going to skip either of those as screens, static site generation, because then you're actually building sites, you're not really building interactive web applications, and then I'm going to skip the kind of two application thing because I say that's crap. So then we start with server-side generated HTML templates. This is the PHP approach I used 20 years ago. It's still a very valid approach for very many cases. If you look outside of the Java world, there's three very, in each of their ecosystems, very popular examples, and I think also the Java world could take some inspiration from those. There's Django in the Python world, there's Laravel in the PHP world, and then there's Ruby on Rails in, obviously, the Ruby world. And what these three have that we kind of lack is very tight integration across all the things. Because sure, you can use Spring MVC and add lots of different libraries, but you still end up having to integrate them together. But with all of these three different ecosystems, you can just get a plugin for, say, single sign-on. Just put kind of somewhere that these are my credentials for the external system, and then you get a login page from that. You get all of these pieces that you probably would have to, at least to some extent, build on your own with the Java solutions we have. The Java solutions we do have, good old JSF is definitely an example of this. Some people still swear by it, but quite many also think that maybe it's a little bit outdated nowadays. Instead, probably the more kind of modern solution is to use an MVC framework, either Spring MVC or Jakarta MVC, and then couple that with a template engine, for instance, Leif. And this is probably something that you all are quite familiar with. Then the next kind of step towards more interactive or more kind of fine-grained interactions with the user is this thing called HTML over the wire. So here we still have the server generating HTML, but it doesn't always generate a whole new page. Sometimes when the user does some small interaction, it just generates a snippet, and then you have small helper JavaScript or something that just switches out that small snippet in that specific part of the page instead of reloading everything. Again, in the big wide world, there's some very popular and I think very well integrated solutions there. One is called Livewire for Laravel, and there's actually kind of lots of people start using PHP just to be able to use Livewire, because it's a very cool way of building these kind of quite interactive things where you have just HTML templates in Python and then a little bit of actual Python code to kind of define which things should lead to what things changing, and it's almost magic. There's also another one which is called Phoenix, which has a live view feature in a programming language named Elixir that almost nobody has heard about, but that's also kind of just that framework, that functionality makes lots of people interested in learning that language, and I think that's quite cool. In the Java land, it's again your favorite MVC framework, and then there's two different JavaScript libraries for configuring things. There's actually two different talks about HTMX here at JFocus this year. I didn't see anyone about Unpoly, but they are quite different, quite same, I mean. Same concepts, slightly different ways of how you do things, but the basic concept is that you put attributes in the HTML you generate on the server, and then there's a JavaScript library that looks for those attributes, and based on that it adds, for instance, form submission listeners. When that form is submitted, it sends a request to the server that the request has some additional attributes that you in your MVC controller can look at, and if that attribute is there, then you don't treat this as a full-blown form submission, but instead you do the same processing, but you just send that updated HTML snippet back instead of sending the whole document back. Talking about these requests and responses and so on, I come to think of one thing. Do you know why front-end developers do go to fancy restaurants? It's to practice handling server responses. But do you know why they eat alone? That's because they don't know how to join tables. Sorry about that one. Then we get to next approach, which is server-side single-page applications. So this is, again, an old concept, like all of these concepts. Next.js is probably the most popular example of this. The idea here is that you build the application as though it would be a single-page application that runs in the browser with, for instance, React. But then you actually run most of that code on the server. So if you're using React, then you run it on a Java server, so that's Node.js. There are also some other examples of this. I think one quite cool one, it's not super popular big, but I think it's very, very interesting. It's called Reflex. It's for Python. And there you write Python code. So, I mean, you don't have any brackets, which makes it weird. But you write Python code that is identical to what you would write in React, and then there's kind of part of the framework, it converts that into actual Python code, React code I mean, that is run in the browser, but then all state management still happens through your Python code on the server, which means that you can do kind of actual access control based on based on security, not just based on what the browser says, and all of these kinds of things. And then it kind of magically just makes those things re-render in the browser. And I mean, it's interesting. You could have a look if you want to learn more. Java players here, I would say, one is Apache Wicket. It's a little bit hard to classify because you could also kind of say that it's HTML over the wire, but I just put it here in the server-side SPA category because it's still SPA-like in the sense that you have a component-based way of thinking. Sure, you still write markup files for the actual structure, but that you do also with, for instance, React, so that's quite same, but it's still more of a component-like approach. And then we have one of those places where I'm biased, so Vaadin Flow, that's a Java framework that lets you do exactly the same thing, so that you write only Java, nothing else, no HTML, no JavaScript, just pure Java, and with exactly the same concept. You have components on the server, they are rendered kind of in a way, sending whatever magic to the browser. The framework takes care of running that JavaScript in the browser, but you only need to think about UI logic running on the server. And the benefits of this, with all these different frameworks, is that you have much easier to access your backend logic, or kind of your business logic from your UI logic, when you don't have to think about the network in between. Final example, or final category, is what I call full stack single page applications. So this is when you have very traditional single page application architecture. You have React or something like that in the browser. You have whatever you want, endpoints on the server, but you treat it as a single full stack application, even though it's technically kind of two parts of it, but you try to keep them together instead of trying to keep them separate from each other. I think one quite cool example of this is called tRPC. That's for kind of TypeScript RPC. So the idea there is that instead of doing REST calls to fetch data from the server, you have a JavaScript server, you implement for that with TypeScript, and instead of defining REST endpoints, you define just TypeScript functions that you mark that these should be callable from the client. So it's more of a kind of RPC kind of thinking. And then based on that, the framework generates TypeScript that runs in the browser for actually making calls to those, which means that kind of you don't need to think of HTTP, but you instead just think of it as running method calls. You need to be a little bit careful because those must be slower method calls, but it's still kind of very, very easy to deal with in that way. In the Java world, one way of doing this is to again kind of take the traditional single page application approach, use something like OpenAPI for first defining your REST endpoints, defining what are all the things I want to be sending over the network, and then based on that, I mean, you can generate server stubs for it that you implement. You can generate TypeScript or client-side code that actually makes those REST calls, and that's it. But what makes this full stack is just that you keep that OpenAPI definition together with both the front-end code and the back-end code in the same repo and so on. When you keep everything in the same repo, you can also take it one step further. So there's, for instance, one cool tool called spring.openapi. That's quite a long name. They are not maybe good at marketing. But the point there is that this tool reads your Spring MVC endpoints, and based on that, it can generate an OpenAPI definition for you. So in that way, you can start by actually thinking of it as code. You don't need to remember how to actually use the OpenAPI syntax, except if you need to debug something. But then the kind of REST is the same, that you use that to generate your client-side things for making those REST calls. And then finally, more bias from my side, we also build a framework called Hilla, which is also the same thing. You define RPC endpoints in Java that should be callable from the client, and then Hilla takes care of generating TypeScript for making those calls as RPC, also sharing kind of your DTO types. If your DTO types have bean validation annotations, then those are also automatically available in the client, so that when you do form binding, you automatically have the same validation rules also in the client as on the server without the application. So to summarize, these are 4 quite different approaches. They are definitely kind of on a spectrum from more static to more dynamic, and they are all different ways than just kind of building 2 separate applications. And I would really want to encourage you to consider any of these. I mean, of course, I think our solution is best, but I think you would probably be better off with any of these approaches rather than being in the trap of building 2 separate applications. So why do I keep talking about these 2 separate applications all the time? What are the actual benefits that we get from follow my excellent advice? Before we get there, one small reminder. Most of you are not working at Google or Meta or any of those really, really big companies. They like to tell the world how to build applications, and that's based on how they build applications. But they have slightly different circumstances usually. They have no problem putting 100 highly paid developers on an important project, whereas most of the people we talk with, it's kind of, well, maybe 10 developers and half of them are very junior and so on. So kind of just it's kind of, for us who aren't Google, it's much more important that we as developers, we can actually be very productive. We don't need to know all the things and kind of waste time on learning those things. And at the same time, for us, we have, I don't know, 100,000, maybe 10,000 users. We don't have a billion users, which means that for us, it's way less important that the server is used as efficiently as possible. It's much more important that the development can be quick and efficient. But really, the reason for doing full stack is it just feels so good. Because you alone are empowered to solve the whole problem for your users. And I mean, it always feels so good when you can help those users. There's this Josh Long, developer advocate at Spring. He was on one webcast saying that I feel drunk with power. And I think that's really kind of, that's the thing here. No matter which of these approaches you use, when you can solve the full problem on your own, then you are really, you are drunk with that power. And of course your boss will also like it, because when you can get all of that done, you are more productive, which means kind of better ratings for the boss, and kind of everything is awesome in that way. How are all these things possible then, you might ask? It's really because all of the stuff that you can avoid. The first thing you avoid is pointless work. Like for instance, like I described with what Hilla does, is it generates client-side validation from your server-side validation. So you avoid the pointless work of implementing the same validation logic twice. Also with kind of HTMX or all of these approaches, you avoid the pointless work of defining REST endpoints, because you don't need them for this front end at least. Also related to that, you avoid all the pointless work of thinking about API evolution for those REST endpoints. Next thing you avoid is bugs. Maybe not all of them, but all this kind of communication layer stuff, that's a really great source of bugs, I know. Has anyone here ever had the case where you have changed the name of a field in a DTO or something, and you didn't find all the places in your client-side code that you needed to update before you actually kind of, next week when someone actually opens that particular not so often used view, it's just broken, and then you realize that, oops, I forgot to update that part. Again, when you keep everything as one application, you very much avoid these kinds of bugs, and that's what makes it feel so good. Even better, you avoid cross-team collaboration. You avoid this situation where, I don't know, you're the backend team, and then there's a front-end team somewhere over there, and then you need to send requirements to them, wait for them to do what they need to do, then they come back and they misunderstood something 1 week later, and then you kind of go back and forth and try to make them understand what you mean, and it's always a struggle. I mean, like you see here also, that that girl, she kind of smiles a bit working with these other teams, but it's really kind of this smile that, can I please be somewhere else now? One of the big reasons for that is just that you end up waiting for that other team. When you're in the front-end team, you always wait for the back-end team. If you're in the back-end team, you always wait for the front-end team. The reason for this is that you have one backlog, they have one backlog. Whenever you need something from them, they don't start working on it immediately. They put it on the backlog. Once they're done with the things that they are otherwise doing, then they start working on your thing. And then when they're done, you're in the middle of something else, and then you kind of wait with continuing until you have finished that other thing. So what happens here is, and this is something that many users that we talk with say, that things that should take one day, kind of the work is just one day of coding, but because of these handovers back and forth, it just keeps taking weeks instead, and that's just something you can avoid. So that was the kind of the cool things. Now let's come to the objections, and I'm going to shoot them down. But there's two things that kind of are good reasons to maybe still not do like I say. The first is if you need offline capabilities in your application, then it becomes a little bit complicated if every interaction needs to kind of run a server-side template to get updates. So there you need at least to go to kind of the full stack SPA solution, but also there might be cases where you're kind of your offline capable client, it needs to be really standalone. So there might be some reasons there to be actually kind of full stack, non-full stack. Another thing, of course, is organization structures. If your company is structured so that the backend team lives in this part of the org chart and the front-end teams lives in this part of the org chart, then you just don't simply change that overnight. It's a long process, and lots of managers need to be involved and so on. But here also, there's this old Chinese proverb, the best time to plant a tree is 20 years ago. The second best time is today. Basically, get started sooner rather than later, because eventually you will have it done, and you can get some small experiments started right away, and then gradually you kind of get the whole organization running in that way once you realize how awesome it is. What are the actual objections that I think don't make sense? You might have seen this image. It was quite popular online kind of a bit over a year ago. It came from a Next.js conference where the Next.js team was launching a new feature named Server Actions. So what we have here is a code snippet. It's a bookmark component, and the point there is that it has a button. When you click that, it triggers a form action, and that action is a JavaScript callback that starts with use server as a tag, and then the next line is just a SQL statement. And people were a little bit upset, kind of saying that maybe you shouldn't run SQL in your click listeners, because that might lead to a little bit of spaghetti code down the line. Again, this wasn't what they encouraged to do. This was how they kind of just showed how powerful this concept is. Because the thing is, with great power comes great responsibility. Of course, when you have that power, you need to use it in a good way. Of course, we all know that we should separate the business logic from the UI logic. But we also know that you should separate your business logic from your persistence logic. You probably don't want to have SQL in your business logic either. But you don't solve that problem by creating two separate applications, don't you? It would be quite silly to have kind of, well, I get the business backend application here, and I got the persistence backend application here, and they are owned by different teams, and they talk with each other over REST. No, that would be quite silly. I mean, even hardcore microservice people say that, yes, the application should own its own data. And the same solutions you use to avoid having SQL in your business logic. Those solutions, they work very well for keeping SQL out of your UI logic also. I mean, there's things like Arc Unit, for instance. It kind of unit tests that look which packages reference which packages in your Java code, and if you have anything illegal there, it flags it, and then you need to fix things. There's also, if you want to be even more opinionated, Spring has this thing called Modulith, which is for creating modular monoliths, and that's also the same kind of thing. So kind of separation of concerns, I think that's a very bad reason to build two separate applications. Because really, people say that they want to have loose coupling. But when you build two separate applications, I think you actually have lousy coupling instead, and that's not good. Next thing that very many are concerned about is that, well, yeah, this sounds fine, but it means I need to learn more things. Who here doesn't want to learn more things? Who here is at a conference learning more things? I mean, we as developers, we all want to learn more things. That's our thing. We get kicks out of finding new ways of doing things. Sometimes, of course, the problem is it might become overwhelming. And I totally agree. 10 years ago, it was overwhelming, where there was actually not just a new framework every day, that's kind of regular, but a new radically different framework every week. That's the challenge. Another thing to remember is that when you do full stack development, it's the team as a whole that is full stack. You can have specialists in that team. You can have one front-end specialist, you can have some database specialist, you can have some DevOps specialist, you can have kind of different kind of specialization. The point is still that the team as a whole works together in a full stack way. Probably, I mean, there's talk about these kind of T-shaped developers, people who kind of know a little bit about everything, but then still there are some pieces where they are really kind of specialized, which means that sure, if there's lots of front-end work that needs to be done, most people in the team can at least help out. They might not be kind of the experts on all of those things, but they can help out when needed. And same also goes in other directions. I actually it was quite encouraging. I saw a state of front-end survey from last year, and according to that, already kind of out of the front-end developers who responded to that survey, 62% said that they work in the same team as a full-stack developer. 70% said that they work in the same team as a backend developer. So I mean, there seems to be some kind of hope here still, but still I'm also way too often I hear stories about kind of these two completely different worlds that don't know anything about each other. More things about managing what you need to learn so that it's not overwhelming is support teams. I mean, when you do DevOps, there's probably a platform team that helps doing all the really tricky stuff. They can help out, they can maybe manage some shared infrastructure, but you as the team doing DevOps, you are still responsible for the actual running of the application. Same with kind of database stuff. Many companies have a team with kind of DBAs or kind of architects that help out with those things, even though it's hopefully if the team itself is still responsible for how they use their database. And for the front-end stuff, this kind of full stack, you can have a design system team, and that team is then able to help out with the tricky things. They build reusable components for you to use that really kind of get all out of the web browser's capabilities, and you can put that together into your actual application. Finally, one more thing that helps is tooling. Again, just like with DevOps, there's lots of DevOps platforms that help you do all of those things, keep track of metrics and so on. And for full stack, I mean, all of these solutions that I explained to you, the whole point of them is that they put together the stack for you so that you don't need to maintain it yourself. And that also, when you don't need to sit there and think, what bundler should I use, what router should I use, what this and that should I use, but instead you have that existing stack that already tells that these things work together, use them and you're good to go. Then you have way less things to learn and worry about on your own. Final objection. There's quite often this requirement that, well, yeah, we got this web UI, but we also need to pass some data to third-party REST clients. So we need to build these REST APIs, these endpoints, and then it would be wasteful to not also use them for the UI, and therefore we need to do the UI in this way that it's a separate application. I think you kind of see that there might be some problems with this way of reasoning. Because the point is, your web UI, it's very specific UI design that guides your users in some specific way. Whereas whatever you have for third-party REST clients, that's as generic as it can be, because you don't know what exact use cases they have. So probably your UI, it needs to have the data aggregated in different ways than what makes sense for a generic REST endpoint. It needs to have different projections, basically different fields selected from all the stuff you have in your database, and so on and so on. So what really makes sense is, if you think that very generic data is good for your users, then you don't build a UI at all. Then you just let them use Postman. But if you actually want to help your users, then you build a UI, and then you also define data access for that UI in a way that makes sense for that UI, because that's the way you make a good working, easy to maintain UI. And the thing is, this kind of data access layer, the endpoints, if you look at how much code goes there, it's not much. So you're actually not even duplicating much code, and as said, it's not even duplicating because they have different requirements, different needs. Another thing that's very important, which is where we get to actually the code example I have highlighted there, is API evolution. When you have those third-party REST clients, they never update. You need to be very, very careful with what changes you do to your REST APIs, to your endpoints, so that they remain backwards compatible forever, because otherwise you have a mess with those clients. So that's why we have everything I have highlighted with the bold and slightly lighter, brighter font there. That's all the pieces that are there only for you to have full control over the API evolution. It serves no other purpose, and it's over half of this small code snippet. When you have a client that is built together with your backend, you don't need to be nearly as careful about API evolution. Sure, sometimes some user leaves the browser tab open overnight, and then if you have updated during that night, they might have some errors at that point, maybe if you don't manage it well. But it's still we're talking about backwards compatibility spanning a day or a week, not a year or two, which means that you just you have completely different needs. And also because your UI, it evolves with, or your UI design evolves with the business, and whenever you change the UI design, you probably need to change how you get data into that UI also, which means that you want to make changes much more often. Finally, we come to microservices. So actually, before we get there, one last joke. This one I'm really proud of. So now I'm building up expectations here. Why do backend developers love monoliths? It's because breaking things into components feels like front-end work. But if you still have that microservice, it doesn't change anything. Because what I just described about having a dedicated data access thing for your UI, that's known as the backends for front-ends pattern. And in a microservice architecture, that backend for front-end, it's just another microservice. It's a microservice that also contains a UI layer for sure, but it's still one service. And then that's the backend for front-end part is the one that calls out to all these other microservices that you have, rather than making it so that you make those calls directly from the front end, because again, that front end has different needs than what your generic services work with. That's what I wanted to tell you. So now we can take a couple of questions, because I didn't screw up timing completely, and then I will wrap up, and then we can have some coffee. So anything on your mind that you want me to clarify or tell me that I'm stupid or any other approaches? Yeah, can start there. Yep. So I can repeat the question, yeah. So the question was, there's sometimes a concern that with server-side rendering, you have more load on the server. It doesn't scale as well as if you only serve the pure data, but not also the HTML. And to a certain extent, that's true. But that's where we again come to the Google discussion. In most cases, with most applications, the time you spend rendering HTML is very, very small compared to the time you spend waiting for the database. So it kind of, I mean, there's always an exception, but in most cases, you're optimizing the wrong thing if you are optimizing that part first. Maybe if you have that very well sorted out, then maybe you might want to start optimizing that also. But in most cases, also like you said, yes, especially if we are on the kind of left-hand side or top hand in my table with kind of server-side HTML templates or HTML over the wire, then yes, those are also very easy to scale because probably it's kind of you don't have much state on the server. Then we get to kind of server-side SPA solutions. Then they might have some state on the server per user that makes it a little bit more tricky. You need to use session affinity and so on maybe, but still very manageable, but still also usually not the biggest concern. Does that make sense? Yeah, I see nodding. Yeah.
Great. So let's assume that you've written your web application in Vaadin.
Yep.
And you want to reuse some existing web components, and those web components takes either JSON or some kind of JavaScript object as input.
Yep.
How can that be solved or not?
Yep. I mean that's
so you actually want to reuse. You have a huge set of libraries of web components existing that you want to reuse.
Yep. I mean that's a very Vaadin specific question. The answer is I can show you the API to do, but there are APIs in Vaadin to be able to pass any JavaScript to those web components also.
I guess there might be a problem if it's assuming a JavaScript object.
Not even that.
Ah.
It's a little bit more tricky, but it's
JSON
still
I can understand, but
yeah.
Okay.
We can have a kind of private QA session afterwards.
Yeah, let's say you have let's say an Angular application bundled together with its own backend, BFF, I guess you call it. Would you consider that as a full stack application in itself, even though it uses, let's say, 20 plus microservices?
Yeah, I mean, from that point of view, it's a full stack application because you haven't separated the business logic, or you haven't separated the server side from the client side completely. At the same time, I mean, all the same arguments I showed you about kind of why, if I find that slide, it's that one. Kind of all of these things that you get problems with when you have a separate front-end and back-end application, you also have the same problems in a microservice structure. So, I mean, I think that's also not a good way of doing it, but I know kind of microservices are popular and so on. But still, if you just can take that small step to have the Angular front end with a BFF built by one team, that's still way better than also having those spread out. So from that point of view, I would consider that progress.
That would make me feel better.
Yep.
Thanks.
All right, now I think, or actually there's just coffee, so it's not such a hurry, I heard. But maybe I don't see any more hands raised either. So let's wrap up. Summarize what I've been talking about. Full stack development, I think, is the future for web development. We got there from the fact that we've been iterating, we've been learning what works, what doesn't work, what are the benefits of all these things, and things don't change as quickly as before, which means that it becomes much more manageable for the team to own the whole stack as a whole. Then I define that full stack is when you don't have two separate applications, one for the front end, one for the back end, but instead one application, one team, one source code repo, one build. The different ways of doing this, you can do server-side HTML templates, you can do HTML over the wire, you can do server-side SPAs that kind of look like a single-page application, but it runs the logic on server, or you can do traditional single-page application architecture, but still keep both parts together in the same repo and so on. The reasons for doing this are, it feels good. You avoid pointless work. You reduce some sources of bugs. You don't need to do all that pesky cross-team coordination. You don't need to wait for those other teams. There are some objections. You are afraid of, or you want to have separation of concerns, but you don't want to have lousy coupling. There's opportunities for the team to learn, but you need to manage it with kind of specialization within team, with support teams, with good tooling. Finally, you might need to have a REST API otherwise also, but you can still use the backend for front-end pattern and actually keep those separate from each other so that the backend you build for your front end is actually good for that front end. That's all I had on mind, so thank you.